Here, particle P is in equilibrium on a smooth horizontal plane under the action of four horizontal forces of magnitude 6 Newton, 5 Newton, F Newton, and F Newton. Okay, these two F Newton acting right angle to each other. Okay, find the value of alpha and F. And if you look at it, between 6 and 5 Newton, okay, these two forces are acting on right angle as well. So that's right angle. Okay, if that's alpha, then that part, little part, should be 90 minus alpha. Okay, so if you have a triangle like that, okay, so if that's 90 minus alpha, then that should be this right angle, so this should be, this part should be alpha. Okay, so imagine this, that's 90. Okay, if alpha is 30 degrees, okay, just imagine this, another triangle. Okay, if that is let's say this is 30 degrees, so this is 90 minus 30, so 90 minus alpha. Okay, so this should be 60. Okay, if that's 60, that's 30. So in that case, if that's 90, so this triangle should be alpha, the angle over here should be definitely alpha. If this is 90 minus alpha, then that should be alpha. Okay, so this is the very first thing that you have to know before you do the resolving forces. Okay, I'm going to resolve the along the y-axis. Okay, if I do that, so you have one force over here that's acting downward. Okay, so you have y over there, and then another y, okay, over here. Okay, so so forces that's acting on y-axis, okay, when I resolve that, okay, for 6 Newton and 5 Newton. So resolving that, so I'm going to equate it to F over here. So if I do that, so for 6 Newton, 6 times by sine alpha, okay, because opposite over hypo, okay, opposite over hypo. So 6 sine alpha, this should be okay, what's on top is equal to what's on at the bottom. Okay, so that's on top, this should be F plus this one over here. Okay, this one over here, which is negative. Okay, but since this is on the other side at the bottom. Okay, that's bottom, that's top. Okay, up and down, so I'm going to equate it, what's on the top is equal to what's on the at the bottom. So F plus, and as I just said, if that's 90 minus alpha, that should be alpha. So I'm going to use sine over here, so you should get 5 plus 5 cos alpha. Okay, 5 cos alpha. Okay, why 5 cos? Because it's adjacent over hypo. Okay, so if I bring that over, so you should get F equals to 6 sine alpha minus 5 cos alpha. Likewise for x, okay, which is parallel to the x-axis. Okay, so resolving that force, you get F, okay, on the left. Okay, this is equal to what's on the right. Okay, on this side, what's on the right. So on the right you have 5 sine alpha. Okay, 5 sine alpha, which is over here, opposite over hypo. So 5 sine alpha plus, okay, and then you have this part, okay, which is 6 cos. Okay, this is adjacent over hypo, so 6 cos alpha. So now if I equate these two, okay, I'm going to equate these two. Okay, so if I equate that, so I have 6 sine alpha minus 5 cos alpha, and this is equal to 5 sin alpha plus 6 cos alpha. 5 sin alpha plus 6 cos alpha. Okay, so just bring it over, collect the like term, so you get negative cos alpha, which is already here, okay, minus 6 cos alpha equals to 5 sin alpha minus 6 sin alpha. Okay, so this is negative 11 cos alpha equals to minus sin alpha. Okay, minus sin alpha. So take the negative over and then divide this by cos. Okay, divide this by cos. So you get 11 equals to tangent alpha. So alpha should be tangent negative 111, which is 84.8 degrees to 1 decimal place. Okay, so once you've got your alpha, you can find what's your f value. Okay, to find the f value, just take one of the equation, okay, either y or x. So your f is let's say 5 sine alpha plus 6 cos alpha. So it's 5 sine, okay, 84.8 degrees plus 6 cos 84.8 degrees, and we use calculator. .523.